direct Chablis. Clear direct Chablis.
Gave you too much, now I'm swallowed.
Discretion, maintain level 240.
Now I'm the fool while you're breaking rules.
Hello everyone,
Alaska
welcome back.
328,
In this
contact
video
Delta
we're
Center
going to do
125,
a little bit of
185.
the atmosphere, temperature, and air, and how it all interlinks into our weather. Alright, before we start talking about air, let's do a little review. What causes weather? Weather, WX equals weather in aviation all the time, and that is due to the uneven heating and cooling of the earth. That is a test question, that's how you should answer it. In order to explain this, we're going to go back to our little Earth, and I'm going to tell you that the first layer of the atmosphere, we're going to call that the troposphere. That's where all the weather happens. Everything happens there. At the edge of it, it's called the tropopause. And in the northern hemisphere, the tropopause is around 30,000 feet, while in the equator, it's around 60,000 feet. And there are several layers to our atmosphere. The first one we talked about was the troposphere, where everything happens, all the weather happens there. That's where we live. It's around 10 kilometers then. Then there's the stratosphere, around 30 kilometers, followed by the mesosphere, around 50 kilometers. Then the thermosphere, way up there, and the exosphere. After that, you find nothing but space. Some of the curious characteristics of the troposphere is that air actually cools as it goes up in altitude versus the stratosphere, where there's very little change. Another interesting factor that happens in the tropopause, and this stops at the troposphere, is moisture. All the moisture is there. Once you cross over that line into the stratosphere, it is dry. Now we're going to talk about the composition of air. Air is 78% nitrogen, 21% oxygen, and 1% others. Now, if we were to grab that air sample at sea level, we'll have that same percentage, 78-21. But if we raise it, say up to 18,000 feet, there'll be half of the air. Still the same percentage, but half of it. This affects weather, performance, and even the pilot's physiology will be affected at that point. So now let's say that you're going to take a flight from sea level and above an 18,000 foot mountain. There's a lot of considerations to that flight. Now, in order to be able to speak the same language anywhere in the world, because aviation is international, we came up with the International Standard Atmosphere. In this case, we speak only in Celsius. We don't speak in Fahrenheit. We also, when it comes to pressure, speak in inches of mercury or millibars. At sea level, your standard temperature is 15 degrees Celsius. Your standard pressure is 29.92 inches of mercury. Now, your standard cooling rate per 1,000 feet is 2 degrees per 1,000 feet, not 1. And your standard change in pressure is 1 inch of mercury per 1,000 feet. That is our standard rate. It may change. It's not the actual. Now we're going to go through a little exercise. We're going to have a sample of air at sea level of 15 degrees C, and we're going to raise that thing up to 10,000 feet. Okay, now let's run through a little exercise. We're going to get that molecule of air up 10,000 feet. That's a 10,000 foot change at 2 degrees per 1,000 feet. That's a total of 20 degree difference. Our molecule of air started at 15 degrees Celsius. We're going to subtract 15 from 20 and will equal -5 degrees Celsius. That's the temperature change between sea level and 10,000 feet. Now let's see what happens to that molecule of air once we add moisture to it. Because once air flows through an ocean or a lake and into land, you're going to get moisture into it, and we have to be able to measure the amount of moisture in the air. So we've come up with a pretty ingenious plan on how to do that. The amount of moisture that air can hold is very dependent upon temperature. The more temperature, the bigger the molecule, the more it can hold. We measure a percentage of dew point. That means we measure the difference between where the temperature is at that point and how much it needs to be cooled down in order to be fully saturated. Hot air can hold more moisture, cool air holds less moisture. Now let's take a sample of air at 15 degrees Celsius. Now let's say we warm it up to 30 degrees Celsius, twice as hot. What will actually end up happening is that molecule will expand and become bigger because it can hold more moisture in it. If the molecule is fully saturated with air and the temperature is 15 degrees Celsius, the dew point will also be 15 degrees Celsius. The same applies to the 30 degrees Celsius particle of air. But now let's assume that that 15 degree particle of air was warmed up to 30 degrees. Now it holds the same amount of moisture, but since the molecule got bigger, it can now hold more. The temperature is 30 degrees, the dew point is still 15 degrees. At 30-30, it's 100% humidity. At 30-15 is 50% humidity. All right, now let's run a real world example. Let's say that air is coming in from the sea up to Southern California, where it's nice and mountainous. Now the air coming in, let's put a temperature of 15 degrees Celsius, standard temperature. And it's got a dew point of 10 degrees Celsius. Therefore, it's got some moisture, but it's not completely saturated. Now the air is going to cool down, we said, at 2 degrees per 1,000 feet. As the air comes in from the coast, let's assume a 3,000 foot mountain ahead of it. As it raises up that mountain, it's going to start cooling down at that 2 degrees per 1,000 feet. So at 1,000 feet, we're going to see the temperature at 13 degrees Celsius, but the dew point remaining at 10 degrees Celsius because it has the same level of moisture. It has not picked up any moisture from any body of water. As it keeps on rising to say 2,000 feet, the temperature will be now 11 degrees, while the dew point stays at 10. If it goes up just a little bit more, the temperature and dew point will then match. When the dew point and temperature are exactly the same, the air will have to release its moisture because it cannot fit any more inside, and it will become a cloud. That is one of the ways that you can start seeing how uneven heating and cooling of the earth can create some of the weather patterns that we see. Thank you for watching the video. I hope you liked it. I hope you learned a thing or two. I hope to bring you more videos in the future. For any information about becoming a dispatcher or aviation in general, please visit us at www.flightopsacademy.com. Thank you.
328, contact Open Center 125.85. 2585, good night, last 328. Singapore 2, descend upon discretion.
Gave you too much, now I'm swallowed.
And flight level 240, pilot discretion, Singapore 2.